Hello, I would like to welcome everyone. Let me present our research, comparative analysis on the influence of high-order terms in Williams series expansion for different cracked specimens, theoretical approach, photoelastic experiments, and finite element analysis. The main goal of the analysis is to construct the multi-parameter Williams series expansion from the experimental procedure of digital photoelasticity method. The important question is, how many terms in the asymptotic expansion have to be kept? To elucidate this problem, the theoretical solutions of linear elastic fracture mechanics based on the complex theory of plane elasticity are analyzed. And based on this analysis, the coefficients of the multi-point Williams stress function for the mechanical fields around the crack tips of two interacting cracks in an isotropic linear elastic material are experimentally and numerically determined. The experimental method used here is the digital photoelasticity method, which is applied for determination of coefficients of the higher order terms of the Williams series expansion for a plate with two interacting cracks for a plate of finite width. The digital image processing tool for handling of the entire set of experimental isochromatic fringes and isoclinic phase maps obtained from the photoelasticity experiments is developed and used. The multi-parameter stress field description with the 15 terms is used. The mixed mode fracture mechanics parameters, especially stress intensity factors, T-stresses, and higher order coefficients of the Williams series expansion are obtained using two methods. Using the classical over-deterministic method in the form based on the stress field and the Broiden-Fletcher-Goldfarb-Charnow algorithm for minimization of the objective function. It is demonstrated that the Broiden-Fletcher-Goldfarb-Charnow algorithm has undisputable advantages over the classical over-deterministic method. The significance of higher order terms in the Williams expansion is demonstrated for the considered cracked specimen. And it is shown that the higher order terms are needed for accurate characterization of the stress field in the vicinity of the crack tip. The experimental stress intensity factors, T-stresses, and higher order coefficients estimated using the proposed method are compared with the finite element analysis results and are found to be in good agreement with results obtained by different methods. Williams series expansion is well known in linear elastic fracture mechanics and has the form where A and K are coefficients are related to the geometric configuration, load and mode of loading. The angular functions are well known, and we can present in the asymptotic form the displacement fields in the vicinity of the crack or tip. And the main question is, how many terms we have to keep in this asymptotic presentation. To answer this question, we consider different cracked specimen. For each cracked geometry, we can find the theoretical solution based on the complex variable C theory of plane elasticity, and these theoretical solutions allow us to compare the asymptotic presentation based on the different kept on the different truncated asymptotic solutions. The results of our comparative analysis are presented here. Here you can see angular distributions of the near crack tip stresses. The red line shows the one-term asymptotic solution, the one-term Williams asymptotic presentation of the stress tensor component sigma 1 of 1 at this distance from the crack tip. The blue line shows two-term asymptotic expansion, whereas the green line shows the three-term asymptotic expansion. One can see that we can keep just three-term in the asymptotic expansion and increasing the distance from the crack tip results in the increasing the number of the terms in the truncated Williams series expansion. The more distance from the crack tip, the more terms we have to keep in the truncated expansion. Then we can apply this knowledge for the experimental determination of the higher order terms in the Williams series expansion. We use photoelastic experiments. We use digital photoelasticity method. The experimental setup is shown here. We study this configuration of the cracked specimen with two non-parallel crack. This specimen is shown to be very useful for the study of mixed mode loading. The isochromatic fringes are shown here for different levels of the load. Factually, we consider different crack geometries. Thus, you can see isochromatic maps for different cracked geometries. Here you can see two parallel cracks, the specimen with two parallel cracks, with two inclined cracks, with two edge notches of equal and different lengths, and the plate with one central crack and two notches. First of all, I would like to say that to accurately take into account the higher order terms, digital image processing is used here. Fringe tracking and fringe order assignment have become the central topic of current research in digital photoelasticity. The skeleton of the fringes is identified first to accurately collect the experimental data from the isochromatic fringes, and the program is written in JavaScript, and the program is specially developed for the interpretation and processing of experimental data from the photoelasticity measurement experiments. Here you can see green points forming the skeleton, the skeleton. And then the classical over-deterministic method and the Broad and Fletcher-Goldfarb-Shannon algorithm are used. The classical over-deterministic method shown here is used in the form based on the stress field. And the Broad and Fletcher-Goldfarb-Shannon algorithm is used to minimize the function. This algorithm is an iterative method for solving nonlinear optimization problem, and the algorithm was realized by the use of package SkyPy optimize of pi, and the results of our calculations are shown here for each crack tip in our plate with 2 x, and to verify digital processing procedure and our results, we perform computational modeling in simulation. The results are obtained by the over-deterministic method and by Goldfarb-Fletcher technique, and the results are shown here. The influence of the higher order terms is underlined here. Points show the finite element solution, whereas red lines show the asymptotic solution constructed by eyes, and you can see that only 20-tone asymptotic solution results in the correct solution. Conclusions. In this research, the comprehensive experimental and numerical procedure for evaluation of the corrective fields using the multi-point Williams series function in a plate with 2 interacting cracks are implemented. Thank you very much for your attention.